Okay, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So in this video, I would like to summarize what we learned in this week, which is the molecular geometry and the bond angle. So the basic molecular geometry, which is the simplest one, consists of one central atom and two bonding atoms. So this is the general shape. So the general formula is AB2. Right? So because it have all bonding atoms, so the electron pair arrangement is linear. Since the repulsion between all bonding pair are equal, then the molecular geometry also linear. Right? And the bond angle is 180 degrees. For linear, we don't have any lone pair because the minimum atom should bind to the central atom is 1. Right, so for the second one is when we have one central atom bonded to 3 atoms. This is the shape. And the molecular geometry, the general formula is AB3. Based on this, the electron pair arrangement is trigonal pyramidal. With the bond angle, 360 divided by 3 is 120 degrees. Since the repulsion are equal, so the molecular geometry also trigonal pyramidal. Alright. The second situation is because we have 3 bonding atoms, we can replace one of the position with a lone pair. So what happened? Alright, so let's say we still have 3 but 2 bonding and 1 lone pair. Now general formula is AB2E. Right? The total is still 3. This one also 3. But what is the difference between it? Because the total is 3, the electron pair arrangement is still the same, which is trigonal pyramidal. But due to the repulsion, the molecular geometry for the second one become V shape or bend with the bond angle less than 120 degrees. Alright, the bond angle is measured between atom, central atom and atom. So we measure here. Alright, okay, and now what happens when we have 4? Let's say we have one central atom bonded to another 4 bonding atom. So we will have this shape. The general formula is AB4. Because the repulsion are equal, the electron pair arrangement is tetrahedral. And the molecular geometry also tetrahedral. The bond angle is 109.5 degrees. Okay. If one of the bonding atom replaced with the lone pair, it will become like this. So the general formula is AB3E. The electron pair arrangement is tetrahedral also because the total is 4. But due to the different types of repulsion, the geometry molecule become trigonal pyramidal. If in tetrahedral, the bond angle is 109.5, here, since the repulsion is quite strong, now it become 107.3 degrees. If we replace the lone pair with if we replace the bonding atom with another lone pair, you will have like this, one central atom, you only have another 2 bonding atom with a lone pair. The general formula is AB2E2. The total is 4, so it is a tetrahedral, the electron pair arrangement. But due to the deep repulsion exists, the molecular geometry become V-shaped or bent, with the bond angle 104.3 or 104.5 degrees. Okay, so now what happens when we have one central atom and 4 bonding atoms? So the bonding atom will be located in this position. Okay, so we have the general formula AB5 because we have 5 bonding pair. The shape is trigonal bipyramidal. We have 2 different bond angles, which is 90 degrees between the vertical and the horizontal line, and between the atom at the horizontal line 120 degrees. Okay, because all repulsion are equal, the molecular geometry also trigonal bipyramidal. Okay, now we will look at the only trigonal bipyramidal have 2 different types of bond angle, which is 90 degrees and 120 degrees. Okay, now we will go to the if one of the atom replaced with a lone pair, right? So it will located on the horizontal line because it want to minimize the repulsion. Okay, so it will become like this. The general formula is AB4E. The electron pair arrangement is still follow 5, which is trigonal bipyramidal. But due to the repulsion, the molecular geometry becomes seesaw, or sometimes we can call it as distorted tetrahedral, with the bond angle less than 90 degrees. If we replace another lone pair, okay, we will have this kind of shape. The lone pair will be located on the central, the vertical line, and this is another bonding atom. Okay, so the general formula is AB3E2. Kalau tadi AB3E2, the total is still 5. So the geometry is trigonal bipyramidal. But due to the repulsion, the molecular geometry become T-shape. As you can see, there is a T shape there, with the bond angle also less than 90 degrees. Okay, and we still have one. We can replace one of the atom with the lone pair because, as I said previously, the minimum is 2 atom left. So in that case, we can put a lone pair around here, AB2E3. The total is 5 trigonal bipyramidal, but due to the repulsion, it become a linear, with the bond angle is of course 180 degrees. Next, if you have one central atom and 6 bonding atom, you will have like this. The general formula is AB6. The electron pair arrangement is octahedral, and the molecular geometry also octahedral because the repulsion are equal. and the bond angle is 90 degrees. I think all are 90 degrees. Okay, what if we have a lone pair? Okay, lone pair can be located at any position for the first lone pair. Let's say I want to put it here and I have another 4 bonding atom. Now A, B, 5, E. The total is 6, so the electron pair arrangement is octahedral, but due to the repulsion, it becomes square pyramidal. Okay, with the bond angle less than 90 degrees. For the second lone pair, it's supposed to locate it on the opposite direction from the first lone pair. So in this case, we have to locate the second lone pair opposite to the direction of the first lone pair. A, B, 4, E, 2. The geometry is octahedral, and due to the repulsion, it becomes square planar. Alright, so the bond angle is around 90 degrees. So that's all. Thank you very much.